In this part of factoring, we're going to look at factoring by grouping. So I wanted to start out with a simple example. You want to use factoring by grouping when you have 4 or more terms. It's usually the best technique when you have 4 or more terms, and it's usually not the best technique if you have fewer than 4 terms. If you have 2 terms, you're going to want to look at factoring out a common factor or difference of squares. If you have 3 terms, you're going to want to try to factor it like a trinomial expression. But in this case, we have 4 terms. So the first thing that I want you to do is split that expression right down the middle. So divide it into 2 parts, a left half and a right half. Then we want to pull out a common factor from each half. So if I look at the left half here, x squared minus 3x, both of those terms have a factor of x. So I'm going to pull out that factor of x. That leaves me with x from the first term and 3 from the second term. So if I multiply that back together, I'd get x squared minus 3x. From the second half of the expression, I want to pull out the common factors there. So we have 2x and 6, and my common factors there are positive 2. If I pull that out, that leaves me with x minus 3. So we've pulled out a common factor. Now what I want you to do is factor out the common binomial that we see in each of the expressions here. Remember, a binomial is an expression with 2 different terms, something like that, right? So we can see that we have a common binomial, x minus 3 and x minus 3. So if I factor out that binomial, what was left from the left-hand side was an x. What was left from the right-hand side was a positive 2. So that's going to factor to x minus 3 times x plus 2. Now this was a relatively simple example, but I wanted to start with that, and now we're going to go into some more complex examples. So first we want to be able to factor some higher order expressions. For example, if we have a cubic expression, if we have all of the terms, we're going to have a cube term, a squared term, a linear term, and a constant. That's 4 different terms. So many times when we have a cubic, we need to factor by grouping. So let's do it. Let's split it down the middle. We'll pull out our common factor from here. 8 and 7 have no common factors, but we can pull out an x squared from both terms. That's going to leave me with 8x plus 7. On the right side, we have negative 8x minus 7. Anytime this third term is negative, you want to factor the negative out with it. So in this case, there's nothing else I can factor out besides the negative. So write that as negative 1. What does that leave? Negative 1 times what is negative 8x? 8x. And negative 1 times 7 is negative 7. So that's going to be 8x plus 7. That's what we want because we want to have a common binomial here. So factoring out that common binomial leaves me with 8x plus 7 times x squared minus 1. And I think you know what I'm going to write over here. Since we're factoring something that's higher order, once we've factored it the first time, we still want to check for more factors from what's left. And you can see we have a difference of squares here. So this is going to factor to 8x plus 7 times x minus 1 times x plus 1. This guy was a squared minus b squared that we factored here. All right, let's look at another example. I'm going to make these harder. What if we have more than one variable? The technique stays the same. We're going to start by splitting this down the middle. We'll factor each of my 2 halves. So looking on the left, we have 24xy minus 8xn. So in the constants, my common factor is 8. And in my variables, both of those have an x in the variable expression, so I can pull out an 8x. That's going to leave me with 3y minus n. On the right-hand side, again, this third term is negative, so I know I'm going to pull out the negative with whatever constant I pull out of the coefficients. We have 21 and 7, so the common factor there is 7. And then in my variables, we have ny and n squared. So my common factor there is n. What's going to remain? Well, let's see, 21 divided by 7 is 3. I pulled out the n, So that leaves a y. And in my second term, be careful, this was a positive. If I factor out a negative, the sign is going to change. So 7 divided by 7 is 1, and n squared divided by n is n. So we have negative 7n times 3y minus n. That's good. That's what we want, because now my binomials are the same. So when I'm done factoring, I'll have 3y minus n times 8x minus 7n. All right, one last example here. Sometimes when you have multiple variables and lots of expressions, you might need to rearrange the terms first. So here's an example of that. I have 28xy plus 7x squared plus 2ax plus 8ay. I think I already rearranged these. Let me give you a new example. Okay, JK, here we go. Now we have a new example. We have 4xy minus 10r minus 5x plus 8ry. And this is an example where I do have to rearrange the terms. So one question you need to think about is, how do you know if you need to rearrange the terms? Well, you can always go by trial and error. If I did try to split this down the middle, there's nothing common that I can pull out of these variable terms, so that's a good indicator. You're going to want terms next to each other that have common variables. So for example, if I were to switch these two terms right here, now my problem becomes 4xy minus 5x minus 10r plus 8ry. Now I can see that both of my first two terms have an x variable. Both of my second two terms have an r variable. That's good because that gives me more that I can factor out of each of the halves. So let's split it down the middle. 4xy minus 5x. I can't pull anything out of the coefficients, but I can pull an x out of each term. That's going to leave me with 4y minus 5. In the second half, 10 and 8, my common factor is a 2. But remember, this is negative, so I want to pull out a negative 2. And then I have an r in each, so I'm going to pull out negative 2r. That's going to give me 5 plus, if I pull out a negative 2, actually that would be minus 4. I already pulled out the r, so now we have 5 minus 4y. So looking at these two expressions, I can see I'm going to have to do a little bit more work. I told you to pull out the negative because that's your safest bet every single time. But in this case, I think I might have spoken too soon. Looking at these two expressions, we can see that they're the same, but the signs are reversed. So what I'm going to do instead here is I'm going to leave this first one the same. And instead of pulling out a negative 2r, what would happen if I pulled out a positive 2r from this? This would have given me negative 5 plus 4y. And that's what we want because that's the same as 4y minus 5. So now we have my common binomial. Factor that out. Whoops, that should be a y. 4y minus 5 times x plus 2r. That's an x right there. Okay, and that's it.